Medical gas alarm wiring must be installed in electrical metallic tubing, rigid metal conduit, or flexible metal conduit, as per NEC 2005 Article 725.11, and b. The entire length of the wiring must be enclosed within conduit. For 120-volt wiring in the medical gas room, install wiring in electrical metallic tubing, rigid metal conduit, or flexible metal conduit. Raceway seals must be used at all penetrations into the manifold enclosures. Install medical gas alarm wiring in electrical metallic tubing, rigid metal conduit, or flexible metal conduit. Raceway seals must be used at all penetrations into the manifold enclosures. The entire length of the wiring must be isolated from other electrical systems. Conduit must be designed to withstand the corrosive effects of medical gases. Conduit must be properly sealed at all joints and fittings. Conduit must be labeled as carrying medical gas alarm wiring. The medical gas room should be well ventilated and maintained at a negative pressure relative to adjacent areas. All electrical equipment in the room should be spark-free. Emergency shut-off valves should be installed for each medical gas supply. The room should be equipped with an emergency evacuation plan. Remember to consult with a licensed electrician and the local authority having jurisdiction for the most up-to-date requirements and best practices. When installing electrical systems in a medical gas room, there are several critical considerations to ensure safety and compliance with the National Electrical Code, or NEC, and other relevant standards. Firstly, the NEC mandates specific requirements for wiring methods in areas where medical gases are present. Article 517, particularly Part D, addresses healthcare facilities, and its provisions often apply to medical gas rooms due to the potential hazards associated with these environments. It's essential to understand the scope of Article 517 and its implications for wiring and equipment in these locations. Secondly, the type of wiring method employed is paramount. While the answer mentions electrical metallic tubing, rigid metal conduit, and flexible metal conduit, the selection should be based on a thorough assessment of the environment and the specific requirements of the installation. Rigid metal conduit, or RMC, offers the highest level of physical protection and is often preferred in areas where there is a risk of mechanical damage or corrosion. Electrical metallic tubing, or IMT, is a lighter weight option that can be suitable for concealed locations or areas where physical protection is less critical. Flexible metal conduit, or FMC, provides flexibility for connections to equipment but may require additional support and protection depending on the application. Thirdly, sealing requirements are crucial to prevent the migration of medical gases into electrical raceways and equipment. Raceway seals, such as sealing fittings and compounds, should be used at all penetrations into manifold enclosures and other equipment to create a gas-tight barrier. These seals must be compatible with the gases present and capable of withstanding the pressures and temperatures encountered in the system. Fourthly, isolation of medical gas alarm wiring from other electrical systems is essential to minimize the risk of interference or accidental energization. This can be achieved by using separate raceways or cable trays for alarm wiring and ensuring that all conductors are properly insulated and grounded. Fifthly, corrosion resistance is a key consideration in medical gas rooms, where exposure to corrosive gases can degrade electrical components over time. Conduit, fittings, and enclosures should be made of materials that are resistant to corrosion, such as stainless steel, aluminum, or coated steel. Additionally, regular inspections and maintenance should be performed to identify and address any signs of corrosion before they lead to equipment failure. Sixthly, proper labeling of conduit and equipment is necessary to clearly identify medical gas alarm wiring and other critical systems. Labels should be durable, legible, and compliant with applicable standards, such as ANSI Z535.1 safety colors. They should also include information such as the voltage, current, and function of the wiring to facilitate troubleshooting and maintenance. Seventhly, ventilation and pressure control are important aspects of medical gas room design. Maintaining a well-ventilated room with negative pressure relative to adjacent areas helps to prevent the accumulation of gases and minimize the risk of leaks. The ventilation system should be designed to provide adequate air changes per hour and should be regularly inspected and maintained to ensure proper operation. Eighthly, spark-free electrical equipment is essential to minimize the risk of ignition in a potentially explosive atmosphere. All electrical equipment in the medical gas room, including switches, outlets, and lighting fixtures, should be rated for use in hazardous locations and should be installed in accordance with applicable codes and standards such as NFPA 70, National Electrical Code, Article 500 through 505. Ninthly, emergency shut-off valves should be installed for each medical gas supply to allow for quick and easy isolation of the system in the event of a leak or other emergency. The valve should be readily accessible and clearly labeled, and personnel should be trained on their proper use. Tenthly, an emergency evacuation plan should be in place to ensure the safe and orderly evacuation of personnel in the event of a medical gas leak or other emergency. The plan should include procedures for notifying emergency responders, shutting off gas supplies, and evacuating the building. It should also be regularly reviewed and updated to reflect changes in the facility or operations. In addition to these considerations, it's important to consult with a licensed electrician and a local authority having jurisdiction, or OJ, for the most up-to-date requirements and best practices. The NEC and other codes and standards are subject to change, and the AHA may have additional requirements specific to the location. Furthermore, a qualified electrician can provide valuable expertise in the design, installation, and maintenance of electrical systems in medical gas rooms, ensuring that they are safe, reliable, and compliant with all applicable regulations. Let's elaborate on each of these points with more technical depth. When it comes to medical gas alarm wiring, the NEC emphasis on using EMT, RMC, or FMC isn't arbitrary. These conduits offer varying degrees of physical protection and, more importantly, provide a continuous grounding path. This is crucial in minimizing electrical noise and interference that could compromise the integrity of the alarm signals. The selection between EMT, RMC, and FMC should be guided by the specific environmental conditions. RMC, being the heaviest and most robust, is ideal for areas prone to physical damage or where corrosive elements are present. EMT offers a good balance of protection and ease of installation for less demanding environments. FMC, while flexible, requires careful installation to ensure it's adequately supported and protected from damage. Now, concerning the 120-volt wiring, the requirement for conduit is not just about physical protection, but also about containing any potential arcing or sparking. Medical gas environments are inherently hazardous due to the presence of oxygen and other gases that can support combustion. Any electrical fault could ignite a fire or explosion. Therefore, the conduit serves as a barrier to prevent the spread of ignition. The raceway seals mentioned are not just any sealant. They must be specifically designed and listed for use with the type of conduit and the gases present. These seals typically consist of a compound that is poured or packed into the conduit body, creating a gas-tight barrier. The selection of the sealant must be based on its compatibility with the gases and its ability to withstand the operating temperature and pressure of the system. The isolation of medical gas alarm wiring from other electrical systems is critical to prevent common mode noise and ground loops. These phenomena can introduce spurious signals into the alarm system, leading to false alarms or, even worse, masking genuine alarms. Separation can be achieved by running the alarm wiring in a dedicated conduit or cable tray, and by using shielded cables to minimize electromagnetic interference, or EMI. The corrosion resistance of conduit and fittings is paramount in medical gas environments. Many medical gases, such as oxygen and nitrous oxide, can accelerate the corrosion of metals. Therefore, it's essential to use conduit and fittings made of corrosion-resistant materials, such as stainless steel or aluminum. Alternatively, galvanized steel conduit can be used, but it must be properly coated and maintained to prevent corrosion. The labeling of conduit is often overlooked, but it's a critical safety measure. Properly labeled conduit allows maintenance personnel to quickly identify the purpose of the wiring and avoid accidental damage or disconnection. The label should be durable, legible, and permanently affixed to the conduit at regular intervals. They should also comply with applicable standards, such as ANSI 535.1. The ventilation and pressure control in the medical gas room are crucial for maintaining a safe environment. A well-ventilated room prevents the accumulation of gases, reducing the risk of leaks and explosions. Maintaining negative pressure relative to adjacent areas ensures that any leaks are contained within the room, preventing the spread of gases to other parts of the facility. Spark-free electrical equipment is a must in medical gas environments. Standard electrical equipment can produce sparks during normal operation, which could ignite a fire or explosion in the presence of flammable gases. Therefore, all electrical equipment in a medical gas room must be rated for use in hazardous locations. This typically means using equipment that is explosion-proof, intrinsically safe, or non-incendive. Emergency shut-off valves are a critical safety feature in medical gas systems. These valves allow for the rapid isolation of the gas supply in the event of a leak or other emergency. The valve should be readily accessible and clearly labeled, and personnel should be trained on their proper use. The emergency evacuation plan is the last line of defense in the event of a medical gas emergency. The plan should outline the procedures for notifying emergency responders, shutting off gas supplies, evacuating the building, and providing medical assistance to injured personnel. The plan should be regularly reviewed and updated, and personnel should be trained on its implementation. In addition to these technical considerations, it's essential to consult with the local authority having jurisdiction, or OJ, for the most up-to-date requirements and best practices. The NEC and other codes and standards are subject to change, and the AHA may have additional requirements specific to the location. Furthermore, a qualified electrician can provide valuable expertise in the design, installation, and maintenance of electrical systems in medical gas rooms, ensuring that they are safe, reliable, and compliant with all applicable regulations. When working with medical gas systems, understanding the properties of the gases involved is also crucial. Oxygen, for instance, while not flammable itself, strongly supports combustion. This means that in an oxygen-rich environment, materials that would normally be difficult to ignite can burn readily. Nitrous oxide, commonly used as an anesthetic, can also support combustion under certain conditions. Other gases like nitrogen, carbon dioxide, and medical air, while not directly supporting combustion, can still pose hazards if they displace oxygen, leading to asphyxiation. Therefore, proper ventilation and monitoring are essential. When selecting electrical equipment, it's important to consider the temperature rating of the equipment. Medical gas rooms can sometimes experience elevated temperatures due to the operation of gas compressors or other equipment. The electrical equipment must be rated to operate safely at these temperatures to prevent overheating and potential ignition. Furthermore, grounding and bonding are critical for preventing electrical shock hazards and minimizing the risk of stray currents that could ignite flammable gases. All metallic components of the electrical system, including conduit, enclosures, and equipment, must be properly grounded and bonded together to create a low impedance path for fault currents. This helps to ensure that overcurrent protective devices, such as circuit breakers and fuses, will trip quickly in the event of a fault, minimizing the risk of electrical shock or fire. Regular inspections and maintenance are essential for ensuring the continued safe operation of electrical systems in medical gas rooms. Inspection should include a visual examination of all wiring, conduit, and equipment for signs of damage, corrosion, or wear. Electrical testing should be performed to verify the integrity of the grounding system and the proper operation of overcurrent protective devices. Maintenance should include the repair or replacement of any damaged or worn components, as well as the cleaning and lubrication of moving parts. It's also important to keep accurate records of all inspections, testing, and maintenance activities. These records can be helpful for tracking trends, identifying potential problems, and demonstrating compliance with regulatory requirements. Finally, training is essential for all personnel who work in or around medical gas rooms. Training should include information on the properties of medical gases, the hazards associated with their use, the proper procedures for handling and storing gases, and the emergency procedures to follow in the event of a leak or other emergency. Personnel should also be trained in the proper use of personal protective equipment, such as respirators and gloves. By following these guidelines, you can help to ensure the safe and reliable operation of electrical systems in medical gas rooms.